In this video, we're going to review trigonometry, so we're not going to practice solving for sides and angles. Rather, it's a revision on labelling right-angled triangles and remembering the ratios, the SOHCAHTOA, sine, cos and tan. In case you're interested about trigonometry, the ancient Greeks did a lot for maths, and lots of discoveries around circles and the use of pi, and also these ratios within right-angled triangles, so these 90-degree triangles, that they have certain properties, as it's written in green there. So the ratio or the fraction of a triangle's side lengths to the angles inside of the triangle. So there's actually a ratio, a connection between them, which leads us to the sine, the cosine and the tangent is what those words stand for. So first of all, we need to identify the sides of a right-angled triangle. The first side that we always do is the hypotenuse. It's a funny word, isn't it? Hypotenuse, tricky one to spell. Now that's always the longest side. So we mark that one first, and it's opposite the right angle. So the right angle there, the 90 degrees, if you were to stand at that angle and walk across the triangle, which side would you hit the hypotenuse? Sometimes we abbreviate that to hype or just H, capital or little letter. Now the other sides depend on where the angle of interest is. So that symbol there that you can see, this one, it's like a letter, capital O with a line through the middle. It's a letter in the Greek alphabet, pronounced theta, or Aussies we often say theta. So the other sides depend on where that angle is. So out of the two left, we always do the opposite as the next one. So if you were to stand in that corner, up where theta is, and walk across the triangle, which of the two sides would you hit? The two that are left over that are unlabeled. The side that you hit would be called the opposite, or we abbreviate that to OPP, and that leaves one side left. Now it's a funny word that we use, it's adjacent. Now adjacent means next to. If we were sitting next to each other, we would be next to or adjacent to each other. Now you might say, yes, but where that theta is, there are two sides that are next to it. One side is already the hypotenuse, so we've already labelled that, so it doesn't need another name. So the one that's left over is next to the theta, or adjacent to, so we call it ADJ, short for adjacent. So that's what our final labelling looks like, or it's also okay to do H, O and A. All right, so an example doing this, labelling the sides. So we're asked to label the sides of the following triangle as the three words, the hypotenuse, adjacent or opposite, based on the location of the angle of interest. So the angle of interest is it's beta, a letter again in the Greek alphabet. You draw it by a capital letter B, but with a longer tail. So always label the hypotenuse first. That's in relation to the 90-degree angle across from that there. So that is H for hypotenuse. And the other two sides, opposite we label first. So you stand at beta and you walk across the triangle, and the side that you would hit over here is the opposite. That leaves one side left, and A for adjacent. Here's some arrows just to confirm what we've done over the top of what I've written, but that's okay. Confirming across from beta is opposite, and the one left over is adjacent. Now, an example here, labelling the sides. This time when we label the sides, we need to use the capital letters that are there between each of the vertices. So first of all, let's label the triangle first with the hypotenuse. We can always do that one, across from the right angle. Let's put the H there. But what about opposite and adjacent? They depend on the angle that we're interested in. And we've got two here. We've got alpha and beta. So we're going to have to go one at a time. So for the hypotenuse, that's this side over here that we've labelled H, but the answers for these are using the two capital letters. So the answer for A would be YZ. ZY is also perfectly acceptable. We tend to go alphabetical order. Now the side opposite alpha. So you'll notice alpha in this bottom left corner here. What is opposite that? Walk across the triangle and you would hit this side, but we need it labelled. So XZ is the answer for part B here. The side adjacent now to alpha, well, it's the one left over if you like, XY. This side along here is adjacent XY. For the next part though, it shows you what it looks like when we label the triangle in terms of a different angle. So beta over in the other corner here, the hypotenuse stays the same, but now the opposite and adjacent swap essentially. Opposite, stand at B, our angle B go across the triangle, and this time you get to the opposite over here, and so that is xy for the opposite side in relation to beta, and the adjacent side is the one left over here, so this time it's yz. So it's really important that the opposite and the adjacent side can change depending on which angle you're interested in. And just a bit of a refresher about the trig ratios. So there are 3 to choose from, and it depends on which sides and angles you're interested in. You may remember, I'm assuming this is not the first time you're hearing this, that the second 2 letters in each of those, it's a mnemonic to help us, I think that's what it's called, to help us remember that. Those 2 letters or words go on top of each other, and the S, the C, and the T relate to these parts of the trig ratios, which stand for sine. It's technically sine with an E. It looks like sin. You can say sin or sine, that's fine. This is cosine, and this is tangent. When I was in year 9 and I remember learning trigonometry for the first time, this is what I was taught. It's probably not very nice. So for the S, the O, and the H, some old hags can't always hide their old age. If you can come up with another one, use that to remember it. But often the students I teach just remember so, ka, toa, and they're able to write that out. Last example here. We're asked to find the sine, cos, and tan for this triangle over here. Let's label our triangle first before we do anything. Always label the hypotenuse first. So we're labeling this one opposite the right angle, H or hype. Now, in relation to theta there, walk across the triangle from theta, and the side you get to is the opposite, OPP, or just O, and then the one left over is adjacent to theta, ADJ. Now let's solve for these. We're asked to find the sine of the angle, so we would write that out. Sine of theta is equal to opposite over hypotenuse. I've put them up the top there as a bit of a revision. What is the opposite length in this triangle in relation to theta? Opposite is 15 and hypotenuse is 17. For this question, that's all it wants us to find. It doesn't want us to work out theta. We'll do that in the next video. Solving the other 2, cos, as we've got up here, is the adjacent and hypotenuse angle. What about I abbreviate that and just write A over H? What is the adjacent in this triangle? We have 8 over the hypotenuse of 17. And then the last one is tan of theta. You're welcome to go straight to the answer if you're feeling confident. That's O over A. The opposite, as we can see, is 15, and the adjacent is 8. Okay, I hope that's been a good revision. There are the questions that connects to. Thank you.